So let's talk about another periodic trend. This one is called electron affinity. Electron affinity is actually the ability of an atom, or we could also talk about an ion, to gain electrons. So it's the affinity it has for electrons. It's how much it likes to get an electron. We can write out what it is for any certain atom or ion x. So it's just x plus an electron gives us x minus. We have the minus because we're adding a negative charge from the electron. So basically, anytime we have a really high positive number of electron affinity, it means that that atom or ion really wants to gain another electron, and it will be very stable and happy if it does so. So let's look at an example of chlorine here. So chlorine, if we talk about it in terms of electron affinity, we would be writing that we're actually gaining an electron here and getting the ion, Cl minus. And the change in energy for this reaction is negative 349 kilojoules per mole. So if we have a negative change in energy for any reaction as it's written, what that actually means is we're giving off energy as the reaction proceeds. So in other words, this Cl minus is actually lower in energy than the reactants were. So that's why we're giving off extra energy. We saw a similar thing as we saw electrons move from different levels. We can think of it in the same type of way when we're talking about actual reactions happening. So if we have energy that's released, would you say that the chlorine ion is more or less stable than the chlorine atom? Who thinks it's more stable? Just show of hands. All right, who thinks it's less stable? Very good. So it turns out it is, in fact, more stable. It's more stable because you actually, this happens spontaneously. You actually get energy out of the reaction as this happens. And we haven't talked about reactions at all yet, so you don't need to worry about the specifics of that exactly, but just that if you have this negative change in energy, you have a more stable product than you do reactant. So we were talking, however, about energy in terms of electron affinity. So we can actually relate electron affinity to any reaction by saying if we have this reaction written as here where we're gaining an electron, we say that electron affinity is just equal to the negative of that change in energy. So for example, for the chlorine case, we would say that the electron affinity for chlorine is actually positive 349 kilojoules per mole. That's a very large number. It's all relative, so you don't necessarily know it's large without me telling you or giving you other ions to compare to. But chlorine does have a very large electron affinity, meaning it really likes getting an electron and becoming a chlorine ion. One major difference between electron affinity and ionization energy is that when we talked about ionization energy, remember, ionization energy always has to be positive. We will never have a case where ionization energy is negative. Electron affinity, however, can be either negative or it can be positive. So let's look at a case where it's actually going to be negative. So if we took the case of nitrogen, if we add an electron to nitrogen and go to N minus, we find that the change in energy is 7 kilojoules per mole. This means in order to do that, we actually have to put 7 kilojoules per mole of energy into the reaction to make it happen. So this is not going to be a favorable process. We're going to find that the electron affinity is actually negative 7 kilojoules per mole for nitrogen. So this means nitrogen has low electron affinity. It doesn't actually want to gain an electron. So that also tells us that the N- ion is less stable than the neutral atom itself.